Could you ever really put enough electrodes into the brain to understand these signals in a meaningful way?
In your time, no. In my time, yes.
Then how many electrodes would you have to stick into your brain, though?
None.
None? Surely you're joking.
You go in from the inside.
And so the possibility occurred to me, actually, that it would be very intriguing to use the holes that are already present in the brain to get to the brain without actually having to go through the skull.
Rodolfo Llinas is really one of the giants in the field of neuroscience. I have friends that actually are neuroscientists, and when they heard that I was working with Rodolfo, they couldn't believe it, actually. They said, wow, how is that possible?
And the holes that I'm talking about are the holes produced by the fact that the brain has vessels, which basically bring oxygen to the brain, may be used as pathways into the brain.
Essentially, we are going to make wires that are smaller than the diameter of blood cells. And we're going to thread them up through the vascular system from a catheter that's been inserted in your leg all the way up into your brain, into the smallest capillaries, the smallest blood vessels there, where the electrodes can be very close to the nerve cells in your brain without requiring major surgery to open your skull up and shove the electrodes into the surface.
And if he can pull that off, then that's going to open up a tremendous wealth of knowledge about the brain and a tremendous ability to alter our brains in various ways. And that's incredibly exciting.
Rodolfo Llinas actually approached our group to help him create a technology that would allow him to navigate a wire through the intricacies of the brain. Although the engineering requirements are actually quite dramatic.
Within a week, I had already produced some preliminary wires for the neural experiments, so it moved very quickly once it started.
Well, I think there was a lot of excitement because for the first time there was a way to access the brain without never touching it. And the brain being such a vital organ, it's quite understandable you want to leave it alone.
So the technology is there. Now the question would be, yes, but can you actually put nanowires exactly at the place you want? The answer is no, you can't. But nanowires are very small.
So 500 nanometers is very small. If you think of it, that's about 100 times less than the thickness of your hair. How do you push the electrode to the brain?
So what you do is you actually send a certain number of them. You have a bundle, and then the bundle would be, the nanowires would be allowed to float into the bloodstream until they can go no further. At the moment, we can wire a rat. We can leave the electrodes in the spinal cord. We want to know, if we do so, how long do the wires continue to work properly. We're talking about 5 years worth of very basic research that needs to be done. It's interesting because it would be almost a perfect way to implement something known as man-machine interface. If you can stimulate the brain, you can stimulate vision, you can stimulate auditory cortex, you can stimulate movement, you can stimulate the passions, you can stimulate desires, you can basically address your brain directly.
Well, I think the idea as a whole sounds very science fiction-like. That idea also being so simple captured people's imagination. They could see and imagine that such a technology indeed could be realized.
If you want to really project and say, would it be possible to feel that you're on the beach and have the sensations and even the pleasure of being on the beach without going by brain stimulation, the answer is, well, in principle, it could be done. What else can you do? Well, you can, of course, in principle, communicate with another person directly. Not only just your thoughts, but in principle, your feelings. So you can get very close to somebody. You can get into their minds. and vice versa. Now, the implications of that are pretty obvious. It may be a mutual situation, or it may be one direction. Somebody gets into your brain, into your mind.
The National Security Agency, the NSA, visited us. And these guys they sort of have a mystique, being members of the intelligence community. The people who came are very smart. They're dressed in suits that cost more than I make in a year. I think some of their interest is potentially sinister.
So, pure fantasy. You could imagine a group of people doing a job in the military, becoming continuously aware of their existence and what they're doing. So suddenly you have not a human, but a group of people that behave as a single entity. We could call this something like a wolf pack. You would have a collective consciousness, a collective understanding. You would be basically a rather strange new device. This happened before in evolution, by the way. We used to be single-cell organisms, and now we are groups of single-cell organisms, as animals. Right?
We'll be able to do things that we can't even imagine right now in so little time that one person could do the work of 20. But at the same time, there are other concerns. If we're able to interface directly with the brain this way, what's to say that the device you're using isn't reading your mind or controlling it? So I think there's a delicate balance that has to be made between how much any device that we connect to the brain is there to help us and how much it's there to monitor or control us. We should be controlling things. Things should not be controlling us.
Now, is this to be done? Should it be done? Can it be done? Well, something like that probably could be done. The upside, of course, is if you can understand, if you can feel like other persons feel, the possibility is that you would understand better. So we could, in fact, become much better human beings, because one thing that we lack often is the ability to put oneself in other people's shoes. The downside is, of course, very clear. You begin to lose your individuality. We will be evolving into a rather different social entity. At the moment, we negotiate. At the moment, our relations are mostly saying what we want other people to hear. We think other people. And we, of course, hide many aspects of what we're thinking. That's, in fact, the basis for politics, the basis for negotiations of any type. It is, therefore, very important for some people not to be totally transparent.
I think that's going to be a big change in the way we interact with reality.
The idea of being able to wire people's brains together in this way to give us the ability to directly beam our thoughts to one another sounds like science fiction. It really does. But basically right now we have proof of concept of a number of these things.
I mean, man-machine interface obviously is one of the things that is going to happen. Absolutely.